In today's world, everyone is talking about the artificial intelligence, machine learning, and deep learning. But what are they? Where to use which particular technology? This is not clear to most of the candidates or the students. In this lecture, we are going to identify those components which belong to individual artificial intelligence, machine learning, or deep learning. Video. We know that artificial intelligence is a superset. This is AI. It consists of the machine learning, which is a subset of artificial intelligence. This is machine learning. And the deep learning is even a subset of this machine learning. So this is a deep learning. Most of us are knowing between this relation between this artificial intelligence, machine learning, and deep learning. But the question arises: do we know an example which is AI but not the machine learning? That means this part. Can we give an example of machine learning which is not deep learning? So it is at this point. And can we give an example of something which could be a deep learning? Means something which falls over here. So we will see how machine learning is different from the artificial intelligence and deep learning is different from that of the machine learning. So this is A, this is B, and this is a C. We will see 3 examples belonging to a different category. Let's take an example. We are having a car. So this is my car. There is a wall. The car is at the distance D from that of the wall. If the distance D is decreased for some value, say for example a lambda, then it should raise an alarm. This type of activity comes under an example of case A. That is, it is a pure AI, but it may not be an machine learning. Next we will see a case B. So this could be fish or it could be a crab. On top of it there is a camera mounted over it and it is capturing the view. Okay. If it is a crab, the element should go in path A, otherwise it should go in a path B. This is a design we need to investigate. Now, how will you identify whether a given object is a fish or a crab? This can be achieved with the help of features. For example, we know that a fish could be a larger in a length compared to crab. So length could be one of the features which is identified. Crab could be of circular shape, fish could be a lengthier, fish have a fin, crab have more legs. So these type of identifiers, which is also called as a feature, are extracted by a designer, and they are used to identify whether a given object is fish or a crab. So, given a feature f, we are designing a model M to predict whether it is a fish or a crab or a 0 or 1 class. Or we can say, given an image X, we are extracting a feature f. From those features, we are training a model M to predict a label Y. This pipeline is known as a machine learning. So here learning is involved. So when we are saying learning, what does it mean? It simply means, for example, we are having this circular notation as a crab in the feature space. Let me put it to it this way. If the length is high, then it can be classified as a fish. So this object can be treated as a fish, whereas smaller object can be considered as a crab. Now, if we can design a hyperplane, or in simple terms, a equation of a straight line which can separate between these two, then we can design a classifier. In simple terms, anything which is left side of this line can be considered as a crab, and anything which is right side of the line can be considered as a fish. And the equation of straight line y is equal to mx plus c, we have to identify it. When we are learning, we are actually fine tuning or getting the value of m and that of c. Here when we are changing the value of m, it is actually rotating the line, and when we are changing the value of c, it is actually shifting it. So it is moving like this. So with the change of m and c, we are finding out which one is the best candidate which can fit or which can separate the data, assuming this one is a line. So in a machine learning, we are identifying what are the best feature which can separate category A to a category B. Here learning is involved, and this learning is done based on the available data. Let me add one more point. Thus, in this equation, x is a input image or a input object, y is a features extracted, m is a model, and this y is a label. Whereas in this diagram, A is my category A, this is the category B, or this is a crab, this is fish, and this y is equal to mx plus c. Here y represent a equation of a straight line. Let me take another example. So we have seen that what could be the example of machine learning. Now we are moving to understand what is a deep learning. So that is a case 3. The question is, in the machine learning, a machine learning engineer or a computer vision engineer are hired to understand which feature is better to be taken care. Something which is not contributing in the computation should be discarded. Finally, deep learning, which becomes a buzzword today and everybody is rushing toward it, have played a crucial role. Here it have changed or modified one pipeline. What is that? To understand this, let's first understand the role of features. We know that from the given input x, we are extracting the feature f. So, if good features are selected, the model can be trained in the good manner. But there could be something, say for example, I have taken a color. But color may not be a good candidate to separate between crab or fish in some cases, where the fish could also be a black or a dark in color. So there will be an overlap. If this is a density function for the crab, this is a density function for the fish. Okay, so there could be an overlap or an error zone which can happen. The target is to minimize this error. So this is a crab, this is a fish, and this is the overlapping region. We have to eliminate this error. Deep learning solves this problem, and it identifies which suitable features are required to be considered from a given image and label. So in simple terms, from the X, in case of a machine learning, feature F was extracted, then model M was built, and it uses a Y as a label. Now in a deep learning, it have changed the pipeline. No more hand designed feature engineering is required. So it is extracting a feature F automatically from a given data X and using the label Y. So as it is automatically extracting the best suitable feature, the results or accuracy is much better than that of the simple machine learning. So in this video, we have seen the cases for AI. We have also seen the cases for machine learning ML and example or a basic concept behind the deep learning. So thank you for your patience, and we will see in the next video in the more detail. Thank you.